So now we're doing the assignment, and the first step is to build the, to formulate the objective function as well as get its constraints. So the first step is our objective function is going to be maximize some z equal to, and so the way we get this is we take the C transpose matrix, multiply it by x. So this will produce 100 x1 plus 150 x2. So now we get its constraints, and the way you do that is you take the A matrix multiplied by x, set it less than or equal to the B matrix. So this gives us subject to 2x1 plus 2x2 less than or equal to 16. Then you have x1 plus 2x2 less than or equal to 12. And you have 4x1 plus 2x2 is less than or equal to 28. And you have to have y1, y2 greater than or equal to 0. So this is our objective function with its constraints. Now we need to plug it into the simplex to get a solution. So we first start by putting it in the initial tableau, moving the objective function over to the left side of the equation, so moving everything toward, like moving the 100 x1 and 150 x2 to the left side, adding slack variables to the constraints. So it produces a tableau like this. So we'll call this row. Then we have 0, 1, 2, 3 rows. You have your z, x1, x2, s1, s2, s3. You have your b. So we're going to, there's only going to be one z, press zeros, move everything over from the objective function to the left. So it produces negative 100, negative 150, 0 slack variables, and right now it's 0. So we move on to the first constraint. So there's 2x1, 2x2. There's going to be one slack variable to set as to make this first constraint an equation. No other slack variables, and the B matrix part is 16. Moving on to the next one, we get 1x1, 2x2, 0 slack variables for s, no, 0 s1 slack variables, 1 slack variable for s2, and 0, and then this will be 12. Next constraint is 4, 2, 0, 0, 1, 28. This is initial tableau. So we're going to look at the most negative number, which is this one. And we are going to do the root test of this column against this column. So the root test. So 16 over 2 is 8. 12 over 2 is 6. 28 over 2 is 14. Now the idea here is that after we do this, we get our pivot point. So we have to get rid of all the negative numbers in row 0. And we do this by we're going to pick the smallest number out of this root test to have as our pivot, which will be this 2 right here. Oh, should be this 2 right here. So let me erase all this. Okay, just didn't erase. Let me try this. Okay, so we row reduce at this point. So the idea is we get rid of this, the negative 150, the 2, this becomes a 1, 0. So what we did in this row is we divided by 2, so we divide this whole row by 2. 6. Multiply it by negative 2, or just what you can do is you can multiply the before we divide it by 2 by negative 1, add it to the row above it and below it, which will produce 0, 3, 0, negative 1, 1, 16. And again, we do that by this pivot point here, multiplying by negative 1 across this entire row, adding it to the row down here and the row up here, which will result in that bottom row. And then we will move up to the row above it. So that will produce, it will look something like this: 0, 1, 1, negative 1, 0, 4. So we multiply this row by 150, add it to the first row to make that a 0, to make this x2 a 0. Whoops, that's not there. Make this x2 a 0. So you're going to have 1, negative 25, a 0 like we wanted, 75, and then 0 here, and then 900 here. So we do, just again with this column, it's going to be this column because negative 25 is the only negative we have left. So we're going to have 4, 12, and 16 over 2, which is 5.3 repeating. 5.3 repeating. So now this 1 will be our new pivot point. So we're doing the same thing we did last time. Let's erase everything in here. So now we're going to 0, 1, 2, 3. That'll be a new pivot point. It's already 1, so we don't have to touch that entire row. So you multiply by 1/2, add it to the bottom row. So we can leave this row alone. 0, oops, that's not lined up. 0, 1, so we're not touching this row, so that we can, yep, that's right, okay. Add it to the, or this will be a pivot point here, and we need to make everything else in that column a 0. So what we do this is multiply by 25 for the first row, or multiply, yeah, first row by 25, add it to row 0, which will produce 1, 0, 0, 25, 50, 0, and 1000. And then multiply this row by 1/2, multiply it by negative 1, and add it to row 2. So this will produce 0, negative 1/2, 0, or, hold on, sorry. This is 1, negative 1/2, 0, 0, 4. Now we take row 1, multiply it by 3, multiply it by negative 1, add it to this third row. So that's still 0, 0, -3, 3, 1, 4. So no more negatives, so we have our optimal solution, which will be, these are pivots. So our optimal solution will be z equals 1000 when x1 is equal to 4 and x2 is equal to 4. Okay, well, that's not a square, but you get the idea. So now the next question states that we must look at the shadow prices, and for each non-binding constraint, the optimal solution. So the non-binding constraint would be the constraint that produces a 0 for shadow price, which will be the third constraint. So we're going to write its constraint 3 as the non-binding, and it's going to be 0.